Hey there, Ayaka. Let's go ahead and dive on into this question. So we're looking at the volume that's created, or the solid that's created from the intersection of a paraboloid and a sphere, and we're looking to figure out the volume. Now, the great thing with this problem is that we were given the hint of looking at cylindrical coordinates, which is going to do an awesome job of condensing things down or simplifying our problem. Okay, so instead of it being, oh my goodness, we needed to figure out triple integrals, instead we can turn it into a solids of revolution problem, one integral, super wonderful and easy. We can totally do this. Ready? Okay. So with the cylindrical coordinates piece, I went ahead and wrote that out in pink. And so we can see that the x squared plus y squared portion for both equations then allows us to go from sphere to what looks effectively like a circle with a radius of square root of 6. And then we have, this one. Let's make sure we finish it up. Okay, we have r squared, which equals z. This, of course, looks like a parabola, right? So maybe a parabola sitting on its side. With that in mind, I went ahead and took this sketch from GeoGebra, which is a super useful tool, by the way. If you've not used it before, here we go. And I turned it on its side so we can see what this looks like. Okay, so this is effectively the z-axis. This is the z-axis. It's right over here. And as we're rotating this thing all the way around, as long as that maintains as a z, it could be anything with regards to that xy. So we're going to call this r, because it in fact is exactly what we're looking at. So now that means that we're going to be going through the whole process of figuring out solids of revolution, which of course means you need to know your constraints in terms of your boundaries function wise. You need to know your limits for your integral, where you're starting and ending. And then of course you're just applying pi times radius squared. In this case, we don't have any inner holes or anything, so we can just simply apply disk method, easy peasy. Okay, so key things here. One, we're going to be using the two equations that are here. I'm going to circle them. I'm going to be using these, whoopsies, these two equations right here to figure out the intersection points of your circle and your parabola, okay? Because that's going to act as the integral limits that we use when we're determining our volume of revolution. Okay. The second piece is that this is going to be not just it's going to be a single integral problem, but it's going to have two integrals. Let me explain what I mean. Okay. When you're looking at this shape, you'll notice that for this first portion, let me put it in a lighter color so you can see it. For this first portion right through here, the volume is going to be defined by that parabola up to a point. Okay. So up to that point right there. Okay, is where it's going to be defined by the parabola. But then after that, it's going to shift, and it will then be, here we go, using yellow, the outer edge, or that outer edge is going to be then defined by the circle. So it's not going to be the same. So let me put this blue one back so you can see it, okay? So these are going to form our two separate integrals. So we're going to do an integral where we go from effectively 0 to this intersection point of the blue and yellow. And then we're going to have from this same intersection point out to the edge of our circle. Okay, so when you're setting up those two integrals, one you're going to be looking at and solving for the points in terms of z where you have intersections. Okay, then your second piece is going to be going, okay, I'm going to have two integrals. The first one, of course, is going to be from 0 to whatever my special blue point is. I'm just going to call that a. And because, of course, we are dealing with a solid of revolution, we do our pi, our parabola piece there, squared dz. And then the next integral we're going to have is going to be picking it up from a, there we go, a, there we are. And we can just call this point out here where the circle, if you will, meets the z-axis to b. And that's going to be doing the same thing with the pi. Now the outer edge on this one is going to be, instead of the parabola, it's going to be the circle squared dz. So I hope this helps. And I know you can do an amazing job. If you have any further questions, just let me know in the comments. Cheers.